All right, good morning, everybody. Wipe the morning sleepies from your eyes and batten down the hatches. It's time to do it all over again. Welcome for the Test 13 review. So let's jump right into it. One coming at us from lesson 50, if you remember what that means. In one room, there's 45 cats. In another room, there's 15 cats. If some cats were moved so that the rooms had the same number of cats, there is your clue phrase. How many cats would be in each room? So we got to get them in the same number. You could go ahead and try to draw a box with 45 and 15, but the easiest way, it will tell you on lesson 50, is just go ahead and find the average. There are two steps to finding an average. First, we have to add all our numbers. In this case, it's pretty easy. We only have two numbers to add. 45 plus 15, those add up to 60. But that's not my final answer. Then I have to go and divide by how many numbers we added. If I added two numbers, I divide by 2. In which case, you'll find out that there would be 30 cats in each room, right? It's about that simple, but sometimes people forget to go and do the second step of dividing. Check out this one coming at us from lesson 60. Tom ate 1/5 of his candy bar. What fraction of the candy bar is left to eat? Well, if he ate 1/5 of it, how many fifths does he have left? Looks to me like he has 4/5 because you just count up how many fifths are left. There would be 4/5 left to eat. Check out this one. From 1895 to 1985 is how many decades? Well, you actually got two steps that you have to do here. Technically, from lesson 49 is a two-step story problem. 35 is talking about time. And we first have to find out how many years there are between us. So you're going to put the largest number on top and go ahead and subtract. 5 minus 5 is 0. Can't go 8 minus 9, so I have to go and borrow again here. 18 minus 9. That's 9. So I have 90 years here. But you got one more step. Now we have to go and think about how many years are in one decade. Hopefully you know a decade is 10 years. So if I want to have the answer in decades, then I have to go and divide my years by 10. 90 years is 9 decades, right? Because if you counted by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, you would do that 9 times. Check out this one. Estimate the product. Hopefully you know product means multiply of 64 and 22 by rounding both numbers to the nearest 10. So 64. Look at the neighbor on the right. Is he closer to 60 or closer to 70? Looks to me like this guy would be closest to 60, right? Because the neighbor on the right is less than 5. 22. Look at the neighbor on the right. He is less than 5 also, so he's going to round to 20. So now I can almost do this mental math. It's not too tough, but I had some people still having problems with this little trick. Count the total number of zeros in the problem. I have 1 0 there, and I have a second 0 there, right? If you have 2 zeros in your problem, you better have 2 zeros in your answer, right? 2 times 6, that's going to give us 12. And then let's just go ahead and write in our 2 zeros. So the final answer would be 1,200. round 3,286 to the nearest hundred. Now, a lot of people are going to trip on this if they're not paying attention, and they're going to try to round it to 3,000. But that's not what they're asking right now. They're saying to go and round 3,286 to the nearest hundred spot. Which digit is in the hundreds? That's the 2 right there, right? So let's take a look. It's going to keep the 3. This is either going to be 3,200 or 3,300. 286, is that closest to 200 or closest to 300? Look at the neighbor to the right. Hey, he's more than 5, so it's going to be 3,300 if we're rounding it up to the nearest hundred, not the nearest thousand. Check out this guy, one from geometry, lesson 61. Which angle appears to be obtuse? Now, I guarantee on the real test, maybe they aren't going to ask about obtuse. Maybe they'll ask about acute. Maybe they'll ask about right. You better go back to lesson 61 if you're not sure of the definitions of those. I'll tell you right now, obtuse means more than 90 degrees, right? The other thing I'm going to go ahead and tell you is that remember when you write an angle, you have to use 3 capital letters and the angle symbol, right? So if we're looking for a guy who's more than 90 degrees, looks to me like if I go from A to M over to D, that guy would go and be your obtuse angle, correct? So how am I going to write it? Angle and 3 capital letters, a capital A, then a capital M, and lastly, you can put in a capital D. Maybe you could do it the other way around and you could call it angle DMA. Check out this guy. On this number line, the arrow is pointing to what mixed number? And hopefully you remember a mixed number is a whole number and a fraction. Here is the whole number 6. Over here is the whole number 7. So I'm going to start off with my whole number 6. Now I got to figure out what's going to be my denominator between whole number 6 and whole number 7 is cut into how many pieces? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I got 10 total little pieces. 10 would be my denominator. Now let's go ahead and figure out my numerator. Here is 6 1/10, 6 2/10, 6 3/10. So this is 6 4/10. Check out one from lesson 57. Here it says, if a number cube, otherwise known as a dice, is rolled once, what's the probability of rolling a 4? Remember, probability means a fraction. So, how many total choices, if I roll a dice, do I have? 6. My probability of rolling a 4, how many 4s do I have here? Only 1. So your probability would be 1 out of 6. Mathematically, for every 6 rolls, probably one of them's going to be a 4. One coming at us from lesson 53. Here it says, what is the length of this rectangle? And that's about the trickiest part. Sometimes kids confuse length and width. Length would be going across this way. So what is the length? 4 centimeters. If you needed to know what the perimeter is, that's the distance all the way around. And kids sometimes forget. They'll just go 4 plus 3, that's 7. But don't forget the other two sides. 4 plus 3 plus 4 plus 3, and that's really going to give you 14 for the perimeter. It's the distance all the way around. Here we have an equation, 4p equals 32. Remember that a number next to a variable means multiply. You really got to think of this as 4 times p equals 32. I don't have any terms to combine, so I can go ahead and start isolating my variable, kick this over to the other side, and do the opposite sign. What is the opposite of multiply? What is the inverse operation? And hopefully you know that the opposite sign from multiplying is dividing. So I'm going to have 32 divided by 4. I now have some terms to combine on my right side, and I'm going to lastly put in p equals 32 divided by 4 is 8. Check out this guy. I still have some people tripping on it. I figured I better run through it one more time. Start off with the digit in the ones. I'm going to go 5 times 3. That's 15. I write down my 5. I carry my 1. Then I'm going to go 5 times 3 again. That's 15 plus the 1 that I carried. That's 16. I write down my 6. I carry my 1. And lastly, I'm going to go 5 times 4 is 20 plus 1 more is 21. Before I start multiplying by my other digit, erase your carry numbers. Go ahead and put in 1 0, and if it makes you feel better, feel free to cross out this digit right here because we're never, ever, ever going to use him again. I now need to multiply by this 20. Don't forget to put in your 0. Start it all over again. 2 times 3 is 6. So I write it down, keep it nice, neat, and straight. 2 times 3 is 6 yet again. And then I'm going to go 2 times 4. That's 8. Go ahead and erase everything we did here. If it makes you feel better, feel free to go ahead and cross out that 2. You're never going to use him again, right? Before I multiply by this 3, put in not 1 0, but 2 zeros this time because that's really 300, isn't it? All right, are we ready to do this one last time? 3 times 3 is 9. Write down my 9. Go 3 times the other 3. That's 9. And lastly, I'm going to go 3 times 4 is 12. Here is my answer when I multiplied by the 5. Here's my answer when I multiplied by 20. And here's my answer when I multiplied by 300, right? The last step of the process, go ahead and add all 3 answers together now. 5 plus 0 plus 0, that's got to be 5. 6 plus 6 is 12. I'm going to write down my 2. I'm going to carry 1 right here. Not back up here in the multiplying, just right up here where I'm adding. 1 plus 6 plus 9, that's going to give me 17. So I wrote down my 7. I carry another 1 right up where I'm adding. 1 plus 2 plus 8 plus 9, that sounds like 20 to me, so I'm going to write down my 0. I'm going to carry my 2 right here. 2 plus 2, hey, that sounds like 4. And lastly, nothing plus 1 sounds like 1. So I end up with 140,725. Pretty easy one here. Remember, when you add or subtract fractions where the denominators are the same, you keep the denominator. So if both my denominators are fifths, I'm going to have an answer that's in fifths. 3 plus 2 for the numerators, that's 5. But you're going to get it half wrong if you leave it as 5/5, because hopefully you know 5/5 is really equal to 1 whole. Here we have one with double-digit divisors. I saw a couple people today making a mistake. They're trying to start off by dividing into 8. Is 40 gonna fit into 8? No way. You got to start dividing into 84 here, don't you? 40 times what gets you close to 84? That answer is going to be 2. Multiply it back for 80. Go ahead and subtract it out for 4. And lastly, bring down your next digit. Time to go and divide it out all over again. 40 divided by 40. Pretty easy this time. Divides in there one time. Multiplies back 440. And it's going to subtract 40. So I'm not even going to have a remainder this time, am I? Just a plain old 21. All right, one more from Fraction Land. We're starting with the whole number 8. And we're trying to subtract 3 and 3/7. Remember, go ahead and borrow 1 from the whole number, but you gotta write it as a fraction with the same denominator. You can't start with nothing and try to subtract 3/7. You gotta go over here to the 8. He's gonna become 7. Bring 1 over and write it as a fraction equal to 1 with the same denominator. If I got 7ths down there, I want to write this guy as 7/7. 7/7 minus 3/7, hey, that's 4/7. 7 minus 3, that's going to give you 4. A pretty easy concept, but I see lots of people getting these wrong simply because they're trying to do them all in their head instead of on a scratch piece of paper. Here we have the 2-step parenthesis problem. Go ahead and do the work in parentheses first. $20 minus $6.65 plus $4. Well, you might be able to handle this one mentally. $6.65 plus $4. That's going to end up giving you $10.65, right? So now I can go and subtract my $10.65 from my $20. But if one number has a decimal point, you got to write them all with a decimal point. So I'm going to take my $20, but I'm going to have to write it in with a decimal point and put in 2 zeros. Then I'm going to take that $10.65 that I wrote kind of messy up there, and I'm going to go and line it up at the decimal points, right? Now I am ready to go ahead and subtract. I have $20 minus $10.65. I got to do some borrowing. Go ahead and pay 1 to the neighbor. Cross them out, write down a 9. Pay 1 to the neighbor, cross them out, and write down a 9. And lastly, go ahead and pay 1 to the neighbor. Now I can fully subtract it. 10 minus 5 is 5. 9 minus 6, hey, that's going to give me 3. 9 minus 0, that's going to give me 9. And 1 minus 1 is 0. If it's at the front of a number, you don't have to write down anything. Nothing is the same as 0. So you end up with $9.35. Last one, divide and write the quotient as a mixed number. Remember, a mixed number is a whole number and a fraction. There will not be a remainder. So I put 39 for my dividend. I'm going to put 4 for my divisor. 4 times what gets me close to 39? Sounds like 9. Multiply it back for 36. And go ahead and subtract it for 3. The remainder is your numerator of your fraction. Your divisor is the denominator, 9 and 3/4, right? So that's about all we have. I cannot stress enough to double check the questions and the answers. Get the rock star math grades that I know you guys are capable of. Keep up the good work. Go slow. Go careful. No silly mistakes, please.